water's what you do. On brand new houses, we've shot holes before. You end up not finding formations, and ultimately you set up pumping out of a pond.
Okay, but tell me about this. Like, where's the water coming in from? Is the screen only on the bottom, or where?
It depends on the well and what you hit. A lot of times, if it's PVC, you just notch the bottom section, and you've got a gravel dumped in your borehole around the outside of it, and then it flows in through that. And if you have your gravel pack up however far, any water in here is going to end up going through your gravel pack and end up into the well. Then at some point towards the surface, you're going to put in around between the casing and the borehole, you put in, it's just called hole plug, but it's bentonite, chunk bentonite, that whenever water hits it, it swells up and it seals up between the casing and the borehole, and that keeps out, but you have your casing go up above the surface. So whenever it rains, you don't want your water from the surface running down the annular space and in and up down here, so that hole plug keeps your surface water out, so you're just getting in very good clean groundwater.
Now, what would you do, like if it's total sand, then you're going to get collapse, like total collapse. So how do you do, would you do this in sand too? Or?
These two holes we drill in completely different methods. I'll start with direct mud rotor, which is what I think you did here. You're going to set up, and you've got...
So hydraulic rotary digging?
Direct mud rotary. There's your drill string. And you probably had a wing bit of some sort on that thing, would be my guess.
Yeah, like that.
You've got a mud pit or whatever you happen to make. You would dig that first next to where you want to drill, and either hand shovel to your mud pit, just a little trough, so the water that comes out of your borehole ends up into that mud pit. Then you suck out of the far end of your mud pit. Depending on depth and a bunch of other stuff, you might dig 2 mud pits. I guess I should do like an aerial view of what's here's where you're going to be shooting a borehole. Kind of dig a mud pit like that, and then you can either hand dig this, a little shallow trough that way, and either stick your suction in right here, and you're going to circulate back around through your drill string down, or if you're on deeper holes or your mud starts getting too thick, you dig another little trough there, and you let it flow over into the second. This is shallow. Say this is 4 foot deep, and this is 4 foot deep. This thing's like a foot deep, so then that tries to get a bunch of stuff to settle out in this first one. As it goes around, then you would suck out of this to circulate back through. And as you drill, you've got to keep your borehole, which it's bigger than the casing. I'll call this outer part the borehole. You've got to always keep water in this borehole. You've got to keep positive head pressure on that borehole. Your static water level in the ground's right here. When you drill, you want to always have water at the top, which as you're drilling, that should normally be that way. That keeps it keeps head pressure pushing out on this borehole. So sand or gravel or clay or everything else that's wanting to fall in, if you've got water up above your static water level, you've got pressure pushing out on it, and it holds that hole open on you.
So probably when we sucked the water, we just basically got rid of that pressure.
You've got to set casing before you remove head pressure on this hole. And you don't always know if it's going to produce water until you set casing, until you put gravel tack, until you develop. You've got to do everything. And then you still might have a dry hole on your hands. And then you go and cry about it, and you drill another hole.
Happened to my family. We ended up paying $30,000 for our well. It was like, first hole, I think it was like 1,500. It was like as deep as their rig would go, and just it got like a gallon per minute.
It's life. It sucks. I mean, on our end of it, it's once a well's down and we have water, I can engineer up everything about it, the pumping system, and guarantee everything about it. Until there's a hole in the ground and water comes out of it, all bets are off. You don't know what you're going to get.
Oh,
and then you get other scenarios of
Mm-hmm.
you set a well and you pump on it for 2 weeks and it goes dry and it never comes back. It's you just happen to have this perched void somewhere that's feeding into it, and you've gotten it dry and you're done. And it may not recharge with rain either if you've got a tight clay confining above it.
Mm-hmm.
All right, you when you drill, to prevent losing water when you drill, as in a bunch of water just disappearing on you as you drill, if you get into sand or gravel, if you just have clean water, it's going to go out into your formation as you drill. Your mud pit's going to start getting lower on you, water's going out into the ground. You mix bentonite in with your drilling fluid, and that makes little, you can't see them, but it makes little platelets that end up kind of sticking to the borehole wall, and that seals up and keeps your water from going out into the formation and keeps this hole full. If you're losing water when you drill and you are below the static water level, that is usually a good sign. It usually means you've got some void space and some porosity to what you're drilling. If water's going somewhere, you can usually get it back out of the ground. It's gotta have somewhere to go, so that's usually good. If you are losing water above what the static water level is, it can be dry sand. It can be, if it's really shallow, it might just be tree roots that rotted off, and then you got little holes in the ground. And you start.
I mean, that's after casing or before casing?
This is before casing.
Before casing.
You still have bit in the ground.
Right.
And you start putting a bunch of bentonite in your drilling mud, trying to clog it up. You do all kinds of stuff, and if it's really shallow, like 20 feet deep, give up on it, move over 20 feet and start over. Even if you have a $200,000 rig sitting there, you start dumping corn cobs, you start dumping everything conceivable in there. It's just shallow. It's something shallow in the ground that's causing a void space where your drilling mud's going to. It just isn't worth the effort, and it may not ever seal up on you, so you move over and you start again. You can set surface casing, and this depends on where you're at. It's where you start losing a bunch of water and you can't circulate. You lose circulation. You can pull your bit up and try to shove a bigger PVC pipe down in that hole and then drill through it. Rarely do we do that just because of what we run into, but some places that's the norm what you do. Or if you drill into bedrock, a lot of times they'll drill down mud and then set a surface casing to bedrock and switch over to air. And to keep that hole from collapsing on them, they've got to do that.
Switch over to air?
Yeah, they'll switch over to air. Because bedrock, you don't need water to hold it open. It's a pretty stable hole, but you need something to hold that. When you're overburdened, that hole needs to stay open. So anyway, you drill that mud, set a surface casing to bedrock, and this could be 200 feet deep though. Then turn on air and blow all this stuff out of this hole, and then run down with air that's blowing all your crud up out of the hole.
When you say air, I mean you're talking like 100 horse or something? Or?
Yes, 100 plus horse. And some of those have air hammers on them that pound, kind of like a hammer drill to drill into concrete. It seems like a lot bigger what's going on, and that
Do you have that kind of stuff too? Or?
We do. Usually we run mud when we drill into bedrock on geothermal loops with a diamond bit. It's usually just faster just to keep going with mud to get a geo loop in the ground. But if you're going 500 plus feet, then you would want to run air.
Because of what it's easier. I mean, it's the volumes of mud that you're losing are too high, or
right. And we usually don't get into a whole lot of fractured bedrock around here too, so we can run mud. And if you do hit a giant void or a fracture in that rock, all your mud in that hole is just going to go, and and run out, and you've got to